Good morning, ladies.
Good morning.
Welcome to Calculus. We're a little bit short-handed today. We got 4 of the class missing. We got a volleyball tournament going on. We have Elizabeth out. Emily's been out for something. I got a email message from Emily with some pictures of assignments, so she's staying in touch, so that's good. But because of our absences, we're going to have kind of a short class today. And I think even though we're short-staffed today, I think it's really important for us to, given the rigor of the subject, and what we need to do is to do something every day, even when we're not going to be able to have like a regular class because of what we have here. So we've got to take advantage of the time we have. So we left off yesterday right here working these limit problems. So let's resume on problem 26 and 27. And here we have, come in.
That was garage chambers. You ran off.
Okay.
Alright.
So we have, maybe I'll be talking to Bryce tomorrow. I'm not sure it was him. Anyway, we have this situation here with this k, and it says let f of x equals x squared minus 2x minus 3 for x is not equal to 2, and x minus 3 for x equals 2. It says find k such that the limit of x as x approaches 2 of f of x equals f of 2. So what we're going to do is just set that up as an equation. And so the limit, we don't know what that limit is, but we know the equation for that limit is just this here, right? So we have x squared minus 2x minus 3, and on the right side we have is equal f of 2. Well, f of 2 is going to have this when x equals 2, so we're going to plug in k minus 3 on the right side. Does that make sense? It doesn't? Okay, let's talk about this a little bit to make it make sense. Okay, do you remember from the other exercise we did where how do we know what is the requirement for something to be a limit? Equal on each side. So left hand limit equals right hand limit, right?
Yeah.
Okay, very good. So what happens is, I'm not sure what it is, but what tells me that both the left hand limit and right hand limit are going to be represented in this expression here? What tells me that? What tells me this includes the right hand and left hand limit? Yes, because what it is, it applies for x being not equal to 2. So everywhere x does not equal 2, this is what applies. And so what it's saying is we're trying to find the left hand and right hand limit where x is equal to 2. Right, what this looks like is this, if we draw a function, if we draw the function here like this, it's going to look something like this. And then over here where x equals 2, right over here where x equals 2, and I'm not sure what that looks like, we're going to have something like this. And so approaching from the right and approaching from the left, we're going to zero in where x is equal to 2. So there's a hole. The limit is not 2. necessarily. It might be when we figure what it is. But the x value is 2. The x value where the limit exists is 2. Because this tells us that. And also what helps us out is understanding here that where x equals 2, this is what applies. So where x equals 2, k minus 3 applies, and everywhere else this thing on top applies. And we're trying to find, it says equals f of 2. So we're going to find what that is, what k has to be. So we have an equation, and what can we plug into this equation? Plug in 2. Let's plug in 2. So we have 2 squared minus 2 times 2 minus 3 equals k minus 3. And so we work this out on the left side, and to me it looks like we have 4 minus 4 minus 3. Is that right? So we have negative 3 equals k minus 3. So what does k equal to?
0.
So k is equal to 0, and the limit itself, does it say, yeah, the limit itself is negative 3, right? Yeah, so negative 3. So right here, the y value here is going to be negative 3. So this hole is located at the point 2 comma negative 3, and the thing only fits if k is equal to 0. So if k is equal to 0, this would be like a horizontal line where y equals negative 3 is what that amounts to. So k is equal to 0. So when you look at it like that, and you really look at it, is this really that hard of a problem?
How did you get the negative 3 on the graphing?
How did I get the what?
The negative 3 on the graphing stick?
The negative 3 came from where the equation.
Yeah, negative 3 came from if k is 0, then negative 3 is right. So at 2, we have negative 3 equals negative 3. So it's asking, is f of, when f of something is, remember we had the deal with the exercises where we had to find left-hand limit, right-hand limit, and then f of whatever, right? We had all those things. Well, here you have the left-hand limit, right-hand limit being the same. So the limit is going to be this thing right here, which turns out to be negative 3 on the left side here. And then we just have k minus 3 on the right, and we find out our unknown k and discover that it is 0. That the thing works out as intended if and only if k is equal to 0. So that's it. And actually the introduction of k as something you're going to see problems like this. To me, the challenge is, because piece by piece the arithmetic is not hard, is it? But it's understanding what to set up from here. To me, that's the challenge of it. That's what it looks like to me. What I want you to do is look at problem 27 and try to set that up similarly, and I'll give you a few minutes to work on that, then we'll go over it here shortly, all right?
Can I answer this one?
Go ahead and answer it, huh? Yeah, absolutely.
Is everyone done?
This will be one, yeah, I'd like to see your answer. What'd you say?
K equals 4.
K equals 4? Okay. Let's go ahead and look at this. So she has here K is equal to 4. Now, from here, we can go ahead and we can just test it, right? So let's try if K equals 4. Then we have, that would be,
Hold on.
4 squared minus 2. That's going to be 16 minus 2, or 14, right? So this would have to be 14. And then it says that x equals 7. Well, here we have x squared minus 49 over x minus 7, and that factors into x plus 7, x minus 7, right?
Yeah.
Over x minus 7.
So that's my son's.
So they cancel out. And so if we plug in, we get, if we plug in 7, we get 7 plus 7 equals 14. So to me, that's going to be your limit, right? And then this is going to be, that looks like that's only going to be the case if k is equal to, to 4. And I think there's one more thing that's sort of bothering me a little bit about that. Anybody else get something else a little bit different? Did you set it up the way we did the other one?
I did like this.
Really? Okay. Because I think I figured out what's wrong here. There's something a little bit wrong. Karina, did you figure it out? Did you figure out, did you get the same thing? Yes? You got something different? What did you get? Yeah, let me show you. And I think Kaylee's answer is right, but it's an incomplete answer, I think. So let's work it out. So we set each side equal to each other. So this is the check, and this did check out. But, so we have x squared minus 49 over x minus 7 is equal to k squared minus 2. And then we go ahead and we said 4x does not equal to 7, so with this cancellation we end up with x plus 7 equals k squared minus 2. And if we substitute in that, we have 14. If we substitute in 7, we get 7 plus 7 equals k squared minus 2, and add 2, so we get k squared equals 16. So Kaylee, that's what you got so far? Okay, what is k equal to? What is k equal to? Plus or minus 4. So k is equal to 4, but also equal to negative 4. Okay? Does that make sense? Okay, good. Because what happened was, when you said that, it looked like 4 was right, but I saw this squared thing, and it just got something going in my mind that, hey, there may be plus and minus 4. And then we work it out, yeah, that's what it is. So that's one thing to look out for quadratic equations, that you can have plus or minus. Okay, but that's still some good work. All right. What we're going to do, I think the volleyball girls are going to be back tomorrow, and I hope Elizabeth is back. So tomorrow what we're going to do is just work here on this one here, limits and asymptotes, note card 3. But I think what we're going to do is do some review on limits, and probably watch some videos on that. There's one that I wanted to watch, and I'll maybe just have the class watch it. So that's going to be our video for class today so far, okay? Any objections? No? Okay.